In this video, we're going to be looking at 5 difficult math SAT questions. These questions were pulled from both the Kaplan study guide as well as the Barron study guide. So let's take a look. This first question, we have a shaded region, which is a square of 12 units, and it's inscribed inside of an equilateral triangle, it says. So we know this A, B, and C, they've all got the same side lengths. So what's the perimeter of this triangle, this outer triangle ABC? Okay, first things first, we have an area of a square. Very easy. Let's just calculate what is the side length of the square. Let's call this side length x. Okay, just going to label all of these as x. Okay, we know that area is going to be 12, and if our area is x squared, then that means to solve for x, we take the square root of both sides. X is going to be, well, square root of 12 can be simplified. 12 is just 4 times 3, which means that we've got, okay, square root of 4 is 2. Square root of 3, we can't simplify that, so x is 2 root 3. Perfect. Okay. What else? So we can also notice here, if we look at our triangle, then we've got this other missing side length here, right? From the edge of the square to one of the sides of the triangle. Let's call it A. Since it's an equilateral triangle, then that means that because of its symmetry, then on the left-hand side, that side length should also be A, right? From the left edge to point C. So if we can find this value of A, then the question should be done. So let's take a look at maybe this triangle, because we know one of the lengths of the triangle. Let's see if maybe we can find out some other information by taking a look at it. And this is the triangle that I'm looking at here, right? I'm just highlighting it right now. Okay, this triangle, let's expand it a little bit. So off to the right hand side of the page. Okay, we've got this triangle here, and it's that side right there is a square, right? So we know that it's going to be 90 degrees. Okay, we also know that since it's an equilateral triangle, that this value right here, theta, let's call it, well, it's an equilateral triangle, so all of the angles have to be equal, and they add up to 180 degrees, so they're all going to have a value of 60 degrees. Okay, we know that the side length is 2 root 3 right here. Okay, so we should notice here we have a 60 degree and we have a 90 degree, so immediately we can tell that this is going to be 30 degrees. And we've got a special triangle, right? Let's remind ourselves what this special triangle looks like, okay? If we've got this special triangle, here, let me draw our standard special triangle here, right? If this was a side length of 2, this is a side length of 1, this is 90 degrees, this is our 60 degrees, this is our 30 degrees, then this is going to be a length of root 3. Okay, so if this is A, right, then that means, okay, well, what can we see here? Okay, we can see that 2 root 3 over root 3, well, that's just going to be equal to A over 1, right? So I've kind of just set it up here like like similar triangles, right? I can see that it's because it's the special triangle. Maybe this doesn't make sense in your head, but you can, however you want to use your special triangle, you can solve it that way too, right? Sometimes you might just learn the special triangle as, if you look at this one, sometimes you'll just learn it as, you know, like x root 3, 2x, and this is x. It's really all the same thing, right? Okay, so we know A is 2. That means that we know that one length of our triangle is going to be equal to 2A plus x, right? Because we've got two values of A here, and then 1x. Okay, a is 2, so that's going to be 2 times 2 is 4. X is 2 root 3. Since all of the lengths are the same of our equilateral triangle, then we know that the perimeter should be 3 times the length, which is going to be 4 times 3 is 12, plus 2 times 3 is 6, and we have root 3. So 12 plus 6 root 3 should be our answer. We can see that that is option B, so we select B as our answer. Next question. If a and b are positive integer constants, and x to the a times y to the b is equal to negative 128, where x is less than 0 and y is less than 0, which of the following must be true? Okay. Well, okay, let's see, what do we know here? Okay. We know that, okay, if x to the a times y to the b is equal to, so we've got a negative number here, okay? We've got some kind of negative number to the power of a, and we've got another negative number to the power of b. Oh, gotta scroll down here. Okay? Let's just think, what do we know, okay? What do we know about when we have negatives to the exponents of some positive integers? Okay? If we have a negative number and the exponent is a positive even number, we're going to result in a positive number. If we have a negative to the exponent of an odd number, it's going to result in a negative number, right? You can check that out. Think negative 1 to the exponent of 2, it's going to be positive 1. But negative 1 to the exponent of 3 is going to be negative 1. Okay. We also know that what we've got here, okay, this is like our x to the a times y to the b. We know that the multiplication of these, or the product of these values, is going to be less than 0. So we're looking for something that's going to end up in a negative. So let's kind of think through here, okay? Okay, let's look at our just the first term here, okay? If a is even, then that means that x to the power of a, right? We can see here, it's this case. It's going to end up in a positive value, okay? So then x to the a is greater than 0. Okay. Then that means that in order for our result, if this first term is going to be positive, and we're going to result in negative 128 from our question, that means y to the b, it has to be negative. So if y to the b has to be negative, okay, let's write this. Then y to the b is negative. So that means that b should be odd. Right, this is the case if a is even. And you could take a look at the other way. If a is odd, that means that x to the a is going to be less than 0. Right? It's like our second case. That means that y to the b would have to be greater than 0, right? If the first term is negative, next term has to be positive to result in a negative number. So that means that b must be even in that case. So let's just look at our question here. We already know that, okay, a does not have to be even, because if a is even, that just means b has to be odd. If a is odd, well, we know that b has to be even. So it's not a or b. Okay? But what we've figured out is that if one of them is even, the other has to be odd. So that means that the product of a and b, well, an even number times an odd number is always going to result in an even number. So therefore, option D is going to be our correct answer, right? If that doesn't make sense, I challenge you. Try to think of any positive integer constants, one even, one odd. Try to think of one that results in an odd number. It's not possible. Okay, let's move on to our next question. So we have a circle that has a triangle inscribed inside, and we can see that it's got 2 of the side lengths labeled as r for the radius, and it's asking us what is the sine of the central angle of the circle shown. So the central angle of the circle shown, we can see that these points are coming to the contact with the edges of the circle. So this central angle here is this value theta that we're looking for. So, okay, we notice that if that's the radius right here, if this highlighted length is the radius, well, that means that this has to be the center of the circle because the radius, right? That means that this other side length that's missing should also be a length r. So we can see that we actually just have an equilateral triangle here. Okay, and this is actually pretty similar to that first question, just set up a little bit differently, right? We have an equilateral triangle with lengths r, and we've got length theta here, or angle theta. Okay, well, we know that theta is going to be 60 degrees. So really, if you know your special triangles, we just know that sine 60 is going to be root 3 over 2. So you can really just finish the question like that. If you want to look at this another way, you can take a look right here. If we split this triangle down the middle, this equilateral triangle, remember this is literally how we construct our special triangle. Okay, if this is length r, let's move on. If this is length r, then this is going to be r over 2. Okay, this is going to be 60, this is going to be 30. Okay, and then we're just looking for this this side length here, right? And remember, this is just like our special triangles, right? We can set it up as like the same way. If this is 60 degrees, this is our 90, this is 1, 2, and root 3. So you can see that in the case here, we've got r is equal to 2, right? Or here, let me set this up a little bit better. If we move this over here, okay, we can see, you know, what's our value, what's our opposite value here? Call it x. Okay, so we know that, okay, x is to root 3 as r is to 2. Okay, so then you can see that x is going to be root 3 over 2 r. Root 3 over 2 r. It's a horrible square root. Okay, and then you can solve it directly that way as well, right? You can see that the sine of theta, in this case, it's opposite over hypotenuse, so it's root 3 over 2r over the hypotenuse, which is r. Okay, our r's cancel out, and it's confirmed. We get sine of theta is equal to root 3 over 2, right? Or a fastest way, definitely you can just jump to realize that sine 60 is equal to root 3 over 2. And then we can see that the answer here is option D. That's our answer. Next question. Okay, we've got 2 parallel lines, L and M. It's asking us what's the value of Z. Okay, this one doesn't look too bad. Okay, well, we are given some angles here. What I like to do is kind of just extend these lines and see what else we can figure out. Let's extend that line right there. We know that we've got that Z shape, which means that this is also 130. And if M is parallel, right, to L, that means that this complementary angle is going to be 50 degrees because it has to add to 180. Okay, we know that if this is 50 and, okay, we've got 110 degrees, it's also got to add to 180, which means that this one's going to be 70 degrees. And now we've got this triangle. This triangle is got to add its angles to 180, right? So we know that 50 plus 70 plus, let's call it x, that's got to be equal to 180. So we can do some quick maths here. Find that that is going to be equal to 60 degrees. And we know that z plus x is also equal to 180 because it's a straight line. So z is just going to be 180 minus 60, or 120. So it looks like option D is our correct answer. Okay, that one wasn't too bad. Let's look at the last question that we have here. Okay, we've got the height of a triangle is increased by 50% and its base is decreased by x%. If the area of the triangle increased by 20%, what is the value of x? This one, you kind of get a lot of information, so let's just write out some of the info that it gives us. Okay, we know that the height of the triangle is increased by 50%. Let's just call this, let's give it h1. If the height increased by 50%, then that means that it's going to be 1.5 times, let's call another variable h naught. Okay, that just means like our initial height. Okay, and it says that its base is decreased by x%. So similarly, well, it tells us in the question actually how you can write a decrease by x%, which I think is a little generous. But we know that it's the same thing that we have above. It's just going to be written as that is our coefficient on our base term, right? So whatever percent decrease of our initial base value is going to be equal to this equation that we have here. And lastly, we know that the area of the triangle is increased by 20%, which means that area 1 is going to be equal to 1.2 times a0, or a naught. So what we can do here with all of this info, we're asking to solve for x here. Okay, and we can totally do this. Okay, so we should notice here 1.2 is also equal to a1 over a naught. I like to set it up as a ratio here because then I can cancel out my unknown heights and bases, because we know that, okay, a1, well, actually let's start with our denominator and then it'll make sense why we're going to do that in a second. Well, a naught is just going to be, okay, it's half base times height, right? B naught, half b naught times h naught. The numerator is going to be half, and then b1, which is 1 minus x over 100 b naught, times the height, which is 1.5 times h naught. And now I can see here, lots of things cancel out. I've just got a bunch of multiplication. My halves cancel out, my b naughts cancel out, my h naughts cancel out, and I'm left with this nice, easy to solve equation. 1.2 is equal to 1 minus x over 100 times 1.5. And now I've just got a single equation with one variable. I can easily solve this. 1.2 over 1.5, that's like 12 over 15, right? And I know that that's like the equivalent of 4/5, right? You can kind of, the way that I think of this in my head is like 12 over 15, it's like 4 times 3, and this denominator is like 5 times 3. So I can cancel out my 3's and I can be left with 4/5, right? That's how I like to think of it, okay? So let me just kind of put that off to the side, actually. So we know that we are left with 4/5 is equal to 1 minus x over 100. Move the x over 100 to the left side. Move the 4/5 to the right side. We get x over 100 is equal to, and 1 minus 4/5 is going to be 1/5. And 1/5 is just 20%, right? So x should be 20 in that case, right? Or you can solve this by multiplying by 100 on both sides. 5 goes into 100 20 times, right? And we can see that x should take a value of 20, which corresponds to option A. So option A is the correct answer. If you made it this far, I'd love to see your questions. So send me, or you can fill out the form in the link in the description, and then I can see if the question would be suitable for another video. And yeah, okay, good luck in your studying. See you in the next one.